Okay, so these are the four main components, and we're going to turn these into a sort of sandwich. We just finished working on the connections on the bottom of the screw terminal shield, and the Pro Mini will just plug in to the top of that shield. Okay, so we'll be just placing this right into those two black grooves of connectors there. And then on top of that, we're going to add the SD carrier, and we're going to peel the protective backing off of the tape and stick it down on top. So that'll make the next layer of the sandwich, and these wires will get brought down to the screw terminal connectors. The power wires will go forward. And then the last component in the sandwich is going to be the RTC board, and the RTC board will go on top. So we're basically making a sandwich of these components and connecting the wires, and the last stage will be to add wires to these backside and bring them around and connect them to the bottom of the board. And then, so one step at a time. I usually connect these two middle pieces first, because then I can flip them over and I can check the alignment before I do any connections to here.
Okay, because they're going to be hidden later on.
Yeah, it's just easier to work with these two first as the middle of the sandwich when they're separate, and I can also visually inspect. Like when I'm pushing this on, I might accidentally break or disconnect some of those wires. So if it's still separate, I can still look underneath it and make sure my alignment's good. So this is kind of the tricky, one of the tricky steps is to just get this in the right place. And the trick is to just get the right amount of overhang. I usually want this board to extend about 2 pins worth. So this board is actually hanging over the backside about that far.
Okay, I think that's better.
Okay, so this is always a slightly tricky step. And what I want is the wires on this side to be just this metal part just hanging off the edge here, so that it's not gonna touch down. I kind of just align it as best I can. You'll have to do a few until you're comfortable with just sort of getting it into the right place when you put these two pieces together. And you only really kind of get one shot at it, or you have to replace the tape because they stick really well. So. So that tape is now exposed. And that tape is exposed. And again, it's a little bit tricky. You're just trying to get this thing sort of lined up so there's a bit of overhang of the SD board. That's probably good. Doesn't have to be perfect. It just has to be sort of more or less in place. And
why were you looking for this overhanging? Just so that...
Oh, the overhang is here. This distance here, from there to there, that's the overhang. This board is slightly off the end. There's the end of the Arduino, and there's the end of the SD board, and they just sort of hang over. And from above, they're sort of lined up pretty well.
Okay. And that's where you're going to be putting the SD card, right? In that one on the
the SD card goes in this slot right here, but it's the middle part of the sandwich. The RTC board will then go on this later. And because of the shape of this chip, these actually kind of line up. You can feel when they're in place because they kind of complement each other. So they actually kind of go into the same place together. Okay, but we'll get to that after we've had a chance to do sort of the other stuff that we need to do here. Okay, so now before I put this down onto the screw terminal shield, I'm going to bring these two lines forward, because these lines, I'm going to solder them. This is the ground line, and I'm going to connect it to the ground pin.
Okay.
And this is the power line, and I'm going to connect it to the VCC pin. Move it to here so that I can work
Okay.
with this mounted on the So the tricky part here is to mark the wire and just put a cut on the insulation and just pull it. Put some solder on the wire and then put it onto the connection. So it takes a little bit of practice, but it's not that hard if you have a good wire cutter. And so there's the ground wire, and I just I want it to go and connect to that pin. That's my ground connection.
This is GND.
Yeah, so I'm just going to mark it, and that tells me where to cut the insulation. And I'm just going to squeeze this so that it breaks the insulation.
And you know,
give it a little pull. Okay, so the insulation there is cut now, and all I have to do is give it a little pull like that, and I've exposed some of the wire.
Okay.
Okay, so that's now available for me to do that.
Oh, you're making a little loop again.
I'm going to make a little loop again. Okay, first I'm going to put some solder on here so that it's
ready.
It's ready. So I'm not trying to join anything that isn't already tinned. So there's a little bit of solder on that wire, so that wire's ready. And I'm just going to heat this up and make sure that this end is ready as well. Okay, so there's some solder on there. I'll just bring this around here. And
Tricky.
it's a little tricky. Maybe I'll even expose a little more wire here.
Yeah, that make it better.
Okay. I'm doing the same thing that I did on the underside of the board. I'm just doing it up here on this connection here. So you see how the wire that's been exposed is now in a loop around the pin. And if I just come in with some solder on my iron and melt those two together, oops.
Careful with the plastic.
Careful with the plastic.
Yeah.
I think I might have messed that one up. Oh, no, it's on there.
Okay.
So that's now the ground from the SD card now connects to the ground pin, and I'm going to actually continue this wire up to the RTC. So the same wire grounds the SD and the RTC. Now we do the same trick again on this pin with the red wire. We're going to cut the insulation, wrap it around the pin, solder it on, and then those 4 wires will go up to the RTC board.
Okay.
Okay. So this is, you know, a little bit challenging. It's not impossible. It's one of those things where if you have a good pair of wire strippers, and I love these Heikos, you just mark it.
How do you know which hole to use? Because if you use
you can read the holes for the size of the wire you're using. Okay, so I know this is 26 AWG, and that's labeled right there, 26. So that's the hole I want to use.
Okay.
The hole that's labeled with the wire that I'm using.
I see.
Okay. So we'll go up to 26. And just squeeze it, and if you get the right size for the wire you're using, it doesn't cut the wire, it only cuts the insulation. Okay.
Perfect.
So we've broken the insulation just enough to do that wrap, and I'm gonna again pre-solder it. Okay. And then I'm going to carefully do a little wrap around. And again, it helps to have these pointy little pliers because you can kind of do a loop around the pliers.
Yeah.
Okay? And that often helps get everything into position here.
And we're again going to the one that's called ground.
VCC.
VCC, okay, perfect.
VCC is the positive rail, which is always red, if you're using the sort of North American color standards.
Yeah.
In other countries, it's different colors, and yeah, you get tired of converting.
Yeah.
So
Okay, perfect.
there you can see the stripped wire, which already has solder on it, sitting right on top of the pin that we're trying to solder it to. That's kind of ideally what you're after here. And then I just carefully hold it in place and I melt the connection into place. There we are. So I melted all the way through, and this is now solid. And then those 4 wires will come forward to the RTC. But the RTC goes on last, so that's the last step in the procedure. Okay. Now that we've got these two joined, we're going to put this onto the carrier board, onto the screw terminal board. And again, we want to make sure we get the orientation correct. So this is the raw and ground pin, and we want to line that up so we're not plugging it in backwards. There's ground and VN, and there's ground and VN, so I have the orientation correct. And sometimes these boards don't exactly fit all that well, so sometimes you have to be careful, and you want to gently just sort of rock it down. This one's going to be awkward, apparently. Okay, so now I have to wonder
why
if my pins are still not quite straight here.
go a bit over there. Yes.
Okay, so this one's being quite difficult. Normally they slide in pretty easily, but this one doesn't want to go. So now I have to figure out what to do. I'm pressing quite firmly. I'm sticking this in and trying to put pressure on the board because I can't just press on the SD board, or we'll end up with touchdowns where the metal goes through to the metal. So I think I'm going to try and just sort of squeeze it down like this. Okay. So
using the pliers.
I'm using the pliers, but I'm being very careful about where I'm compressing it.
Yeah.
I'm just putting pressure on that board and really nothing else. Just on the edge here. There we are. Okay. So now the Pro Mini is in position on all of those pins. Okay, so instead of using the pan of ice, we're just going to do this by hand. The reason I wanted the offset on this board is if you pull it back far enough, it actually helps these connections move them into alignment. So this connection here just goes straight down. Remember, the labels on this board here are not correct. These are not the right labels, because these are the labels for a Nano and this is a Pro Mini. So this is actually going down to pin 13 on the Pro Mini. And I usually just give myself about ½ centimeter past the board. So about there, and then I cut it. And then I strip that. Give it a twirl, just to hold the wires together. Okay, so that we can just tighten this down. And I'm pretty careful about the tension. This is something that takes practice to know how tight to make this so that it's squeezing the wire firmly, but you're not going to break the connector, because if you push these really hard you can just snap them off. So it's one of those things where you want it to be firm, but you don't want to just go crazy and have it break on you. Otherwise you have to make a new terminal board. Okay, so that one just gets pulled down to there and cut. Strip the end, give it a little spin. Undo the connector.
And it's better to start from the edge all the way to the.
See, and that wire got bunched up, so I have to pull that out, give it another twist. It didn't go in smoothly.
So what you're doing when you unscrew is you kind of increase the space, right?
Yep. And when you tighten it, the little metal jaws come down and they grab the wire. And it's these kind of connectors work better with dry wire. Now those two literally just go down and straight down, and these two cross over in this pattern, the way this board is laid out. Again, if you're using a different SD board with a different set of a different connection order, these would go into a different order. Okay, so there's our last connection.
The brown one.
Anyway, on the instructions on the website, it goes into details as to which connection this is, but this is just showing you the...
How far in does it have to go? Just basically what you were showing, right? You don't
I
have
was
to put
cutting
that
about
much.
6 millimeters of insulation off,
Okay.
and this is about 5 millimeters deep.
Okay.
So, and you know, I pulled it past the board and I trimmed it about 5 millimeters just past the edge of the board, and that gave us enough room for this fold to go nicely. So at this point, the SD board is completely connected to the Arduino. The power and the ground are connected, and then these 4 SPI bus wires are connected.
Okay.
Okay, so that's now, we could even put a card in there, plug in the Arduino, and test it if we wanted to see if the connection was good. I'm going to keep working through here, just because at this point, you know, it's not that many more connections to do to just finish this to the point of testing the unit. Okay, so now SPI bus is connected to the SD card, and now we're going to connect this guy to these 4 connections here. 1, 2, 3, 4. 4 wires, 4 connections. So now we're going to make the sandwich. Okay, and then connect those two. So the sandwich is a bit tricky. Again, it's better to bring these together when they're still not sticky, so that you can get a feel for where that wants to be. Like, these sort of have a natural place to go together, and they feel connected in that one position. It's when the edge of the chip is up against the edge of the metal.
Okay.
It just sort of slides together, and then you pull it back, and it sits in place. So there's a natural place where those want to be together.
Okay, can we zoom in on that part so we can see? Okay. Okay, good.
Okay.
Okay.
So this edge right here goes up against the chip. Okay?
Okay.
And it fits. It just sort of jams into place there. Now right now they won't stick because I still have the plastic on top of the tape. But you can feel that position. You know when you do that, they don't want to move. They're in the right place. Is right there. Okay? So it's worth it to bring them together before you uncover the sticky surfaces. You need to know, that's where it wants to be. Okay?
Sounds good.
So now we flip that up. And the idea was that this tape covers all the metal can, so we can't get any touchdowns on the circuitry of the next board. Okay, so now when I bring them together this time, they're going to be stuck.
Okay.
And so I need to get this right. But so that was why I was saying it's good to practice this so you know exactly where they want to be, so that you can push them into place, and it's in the right place right from the beginning. And the nice thing is it's kind of aligned vertically, and it's aligned like the beginning of the Arduino and the RTC board and the end of these rows. It all kind of, when you get it right, it lines up really well. But the key is to just sort of do it a few times so you can feel where that place is. So I knew exactly where to squish that down.
Let me zoom in so you show. Nice. Cool.
Alright, so you're going to have to zoom out for the next bit, because this needs to be held in the vise while we do the next 4 connections. Okay, so the 4 wires that we brought forward, the positive rail, the ground, and A4 and A5, these are essentially the 4 wires that form the I2C bus. And the RTC is an I2C device. So we need to connect these 4 to the RTC. And then at the other end, we'll connect the wires that go out the other side to some of the screw terminals along the side. But this is a little tricky too, so we'll work through this. The idea is we need to cut this wire so it's the right length to just go through the hole. The first hole here on the RTC, if I flip this over, this is the order. We got ground, VCC, SDA, which is the data, and SCL, which is the clock for the I2C bus. So that's the order of our pins right there: ground, VCC, SDA, and SCL. And I always use white for SDA and yellow for SCL, so I know from the colors which order to put these in.
That means we have to put the red next to the black, right? So that's
Yep.
yeah.
It just means we have to be careful, and we don't want to bridge our solder joints. But the first step is to just get the lengths cut to the right wire length, and stripped and tinned. So that's the first one.
Okay. I think maybe good if we zoom in a little bit.
So a little bit of flux and in the wire. And you don't want the wire to get all fat and blobby. It's got to stay thin.
Because it has to go through a hole.
Because it has to go through a very tiny hole here.
Nice.
Okay, once it's in, it sort of usually stays in place. And then you bring in some solder and you finish off that join.
Make a little kiss.
A little Hershey's Kiss.
Yeah.
There you go. So now we're going to do the next 4, remembering the order of our pins, right? So the next one is VCC, which is the red wire, then white, and then yellow. So we can just hold it in place. That sort of tells us how long to cut it. I usually leave it a little bit longer than it probably needs to be. And that just makes it easier for me to get a hold of the wire and do the stripping. Okay, so there's the did the wrong wire next. Actually, the next one needs to be red.
That's what I was thinking, but anyway.
Yep, no, I got the order wrong. But I mean,
Yeah.
just trimming and cutting them
Won't hurt anyway.
won't hurt, so I'm just going to make them all the right length now. This is one reason why to make it a little bit longer than perhaps you need, so that if you make a mistake like that, you can just stretch it over to the left or to the right a little bit more.
Does it matter if the red goes over or under?
No,
No.
whatever's convenient. There's no order. Like you can do it this way,
Okay.
or you can do it under. As long as the wires are sort of neat and tidy, doesn't particularly matter. You don't want the wires sticking out. That's the only real question mark. So if you want to use these wires to keep that in place, you can sort of fold it like that. But it doesn't actually matter one way or the other.
Okay.
It's a little bit long. Just gonna turn that down. And then the red wire is over here next to the black.
And those connections you shouldn't put a lot of solder so that if you put too much, then they'll touch and then.
That's right.
Yeah.
But that's true of pretty much every connection. You just want to have enough for it to make the little Hershey's kiss, and then that's it. And if you're having trouble holding things in the right place, you can first get the join soldered like this. And if I wanted to push that wire back in, I can grab the wire and then remelt the solder. And move it into place so it's a little neater. So you don't always have to get it perfect the first time.
Okay.
Okay, so that is now the RTC connected to the bus.
Okay.
And I'm just going to trim away the excess here so those aren't too long. I'm not going to cut them flush because if I made a mistake I'll have to pull those wires back out, or if the clock is not working I have to pull those wires back out and replace the clock. So I don't cut them flush until I'm sure everything's perfectly working.
Got it.
But I just make them a little neat and tidier. Okay, so now we go to the other side of the clock and we work on these wires. So now that the other side of the RTC board, this side, is connected at the front of the logger, these wires pass all the way through the RTC to this set of connections at the back. So these devices are I2C devices and they all get connected in parallel with I2C sensors. So all of these things that are on the bus, they all get connected to these 4 wires together. And so we have a pass-through of 4 wires. Now if I flip this over, ground we've already connected with our extended pin. We had an extended pin there. VCC, SDA, SCL, those are the 3 we're going to bring to the unused pins. We have a few unused pins here, so they're going to get brought down through the board and then connected to these 3. And then the alarm line is SQW, and that'll get brought back all the way to D2 under the board. So only the middle 4 actually need to be used for what we're doing. And just to remind myself of that, I'm going to bend them down slightly. It just makes it a little easier to work on them. These are the 4 that I'm actually going to be connecting wires to.
I see.
Right, the ones on the end we're not actually connecting to. We might in some future use for a logger, but we don't need them right now. So those are the 4 I'm connecting. VCC, SDA, SCL, and SQW. Those are going down to the bottom of the board. Now to fit all the wires through, we have to use 30 AWG because it's tiny wire and it will fit through the hole without us having to drill any extra holes. So we're going to use these wires because they're tiny.
And the same colors correspond to what you had before, because it doesn't really matter.
Yeah, I'm going to use the same colors. Blue is the alarm line, so I'll run the alarm line through, and then the other 3 will just get connected here to these unused terminals.
Okay.
So let's do the blue one first. And again, you strip the wire, give it a spin, tin the wire with some flux. Okay, and I'll trim it a little shorter. And a little more solder on my iron, just connect it to the pin. And it's fairly quick because we already had solder on those pins, right? We soldered the pins before. So now that wire can go through the little hole, and we can flip this over. Okay, and that's the alarm line that has to go down to D2 down there. So I just take it to the pin that I need, hold it in place, wrap it around, give it a little cut.
Okay.
Okay, so now it's the right length. Strip the ends, make a little loop. Okay, so there's the wire exposed. Put a little flux on there. Okay, so now there's a little eyelet of wire around the pin that we wanted. Bring in my solder.
Perfect.
Okay, so that's done. And we're going to do the same thing, bringing 3 wires over here, 1, 2, 3. And it looks like we got another cold solder joint. I'm batting 1,000 here today.
Yeah, well, it's good to show those. So
Good
that
to you,
we know
for
how
you
to
to
fix
see
them.
this, but I'm just so surprised. I mean, I never do these usually.
It's just because you are being recorded.
Of course.
Yeah, yeah.
Alright, so I'm just going to hold that down. I mean, I can't remember ever having 2. That's just what?
I think you are tired.
Yeah.
You're doing too many. Okay, seems it's on now.
Too tall.
Yeah.
Okay.
Okay.
So now we flip this back over.
Okay.
And I'm gonna do the next 3 wires together.
So yellow is for data? No.
Clock.
Clock.
Normally, that's just my color convention. You
Yeah.
can use any colors you like. Okay.
You're cutting the ends because they're blobby, or just because
Just
it's
a bit
so
too
long?
long. It's just a bit too long for my comfort.
You want the wire, like the strip wire, to be about the same length as the pin, more or less?
Yep.
Okay.
So I'm working at a slight angle here, so those are not as pretty as I would like, but they'll do.
Mm-hmm. Nice.
Okay, and the ground pin here we don't need because we already put ground on this side. So we're just going to bring these 3 wires over this way to the 3 terminals we don't have connected. See, these are empty rows here.
Mm-hmm.
I'm going to bring these to there.
Okay, bring it.
I'm going to have to
Hold it somehow.
hold it with my left hand,
Mm-hmm.
which is a little difficult from this angle. Normally
Yeah.
I would just spin it all around and work on it.
You can spin it all around if you want.
Okay.
Make your life easier for a change.
Okay, so
Perfect. That makes more sense.
It's a little close for comfort there.
Yeah, I know. I
On
was
that joint, so I'm gonna try and pull that back a little.
okay.
It's too close.
Mm-hmm.
So I pulled it too far. Again, because I'm
Connected.
working from the wrong side here.
Yeah, you can just turn it around. That looks better.
Okay. So I'm using these pliers, but you can also bend the
Move it a bit
you can also bend the loop with your tweezers. Right?
closer. Okay.
Pliers give you a little bit more strength when you do the turn, but if you don't have them, you can still use a good pair of tweezers to do the loop on the end.
Okay.
Okay, so right now we've got basically everything except the indicator LED. That's the bottom of the logger. There's the SD card connected to the SPI bus. This is the I2C bus, which connects to the RTC, and then we pass the connections through to those 1, 2, 3 connections, which come out here, and this is where your sensors would get connected to, those 3 plus one of the ground lines. And we have extra ground lines because we repurposed these pins here are both ground and these pins here are both VCC. So at this point I label things that I've repurposed on the outside. So let me get my markers here. And the 2 pins that we converted to VCC, okay,
Yeah.
if we look at, that's the reset, it's no longer reset. Those
Okay.
are both now the positive rail. Okay, so I usually mark them. And this red line down here, it goes around and it's another positive, so I mark that.
Okay.
So those 3 are all connected to positive 3 volts. And we've also got 3 connections on this logger to ground. One is over here at the end, and that goes to this pin here. So that's a ground. So I usually mark the grounds
In black.
in black. And over here, we had a reset pin which we repurposed, so there's 2 grounds. So I mark that those are both grounds as well. So power and ground, there's actually 3 now distributed across the unit. Very useful. And just to remind myself that this is the clock line and this is the data line, I usually put a C and a D. That's my I2C bus that has passed through the RTC board. Okay? And then finally, we've connected the voltage divider to pin 6. So I usually just label these so I can keep them straight. So pin 7 is right beside it, and it's not used, but 6, I know, under the board is connected to my voltage divider.
Okay.
So I shouldn't really connect anything to that. That's already in use, but this one's not used. So I often put things like thermistors and stuff on that 7th pin. But that is essentially the completed logger, with the exception of adding an RTC battery, putting an SD card, and an indicator LED, which I usually run on these pins over here. Okay?
Okay.
So we can take this upstairs and test it.
Okay, super.
Once the unit has passed its tests, the last step is to take the conformal coating and coat all of these contacts along the bottom of the board, because even though I've been really careful about cleaning everything at every step along the way, I get out the isopropyl alcohol and clean it, there's inevitably some flux left, and you don't want any of these contacts oxidizing. You know, when a unit is in the field collecting data, you want these to be really, really, you know, as well protected as you can get. So once the silicone is dried for the conformal coating, I'll put 2 strips of double-sided tape along the edge, and it's actually going to be 2 layers thick, and that's the adhesive that will hold the logger in place inside the housing. So there's just be 2 strips along the outside edge, 2 layers thick, and that lets you just flip it over and mount it inside the housing.
Cool. Okay.
Okay.
Great.